This is lesson 11.5. Today we're going to talk about the volume of prisms and cylinders. So recall a prism is a solid that has two bases that are congruent and parallel. So in this picture, we have two triangles in the picture connected by a bunch of rectangles. So the triangles are considered the bases. The height of a prism is really the distance between the two bases. And it could be slanted or it could be straight up, and it's not going to make a difference. It's still the total distance between the two bases. So here we would be calling the top and the bottom the bases, and then the height would be how far apart they are. So it will not always be a vertical distance, because if you think about it, when you lay down in bed, your height is now horizontal. So if the bases are on the sides, then the distance between them there would have been considered the height. So our formula is going to be B times H, and B is the area of the base. That's why it's a capital B now, right? Lowercase b usually meant the length of a base, but capital B, the area of the base, and H is the height between bases. So it's just B times H. So in our first problem, let's call this part here the base, right? The bottom and top could be the bases. So when I want to find the area of the base, that's length times width, or 9 times 17. And 9 times 17 is 153. And the height, the distance between the top and the bottom, is 24. It's also the only number we haven't used. So my volume is going to be 153 times 24, which gives me 3,672. And now volume, because there are 3 dimensions, will be units cubed. So this is centimeters cubed. You go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so I considered the side that had dimensions of 8 and 12 to be the base, so I found the area of the base is 96. The height then was 39, so the volume was 3,744 cubic feet. Now this is a triangular prism. If I look at the front and the back here, they are triangles. So I'm going to use the triangle to find the area of the base, and we know the formula for area triangle is 1/2 little b times h. So that's going to be 1/2, and if I looked at this triangle, I'm going to draw it so the right angle is up like this. So this distance here was 7.3, this distance here was 12. So that's going to be 1/2 times 12 times 7.3. And when I do that, I get 43.8. The height, which is then the distance between the bases, if I look here, the height is 5. So my volume is going to be 43.8 times 5, and I get a total volume of 219 cubic feet. You go ahead and try the next one. Pause. When you're ready to see the answer, hit play. All right, so the front and back were my bases. Then the area of the triangle, 1/2 times 11 times 5.4, we got 29.7. The distance between them was 16, so the height is 16. So my volume was 475.2 cubic millimeters. So example 3, you are building a rectangular chest. You want the length to be 6 feet and the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? So if we consider the base to be made up of the 6 and the 4, so length times width is 24, and we don't know the height, but we do know the volume is 72. If I take the formula for volume, plug in 72 for V, 24 for B, and we don't know H, I could divide both sides by 24, and I get 3 is my H, so that would be 3 feet. So you go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so my area of the base was 46.8. So we have 46.8 H equals 655.2, and I get H is about 14 feet. So now we're going to look at a cylinder, which can almost be viewed as if it was a prism because it does have two bases and it's connected. So if we consider the base to be a circle, and we know the formula for area of a circle is pi r squared, instead of BH, we have pi r squared H. So V equals pi r squared H is the formula for the volume of a cylinder. So in this example, we know that R is 18 and H is 15. So when I do pi r squared times h, I'm going to find the 18 squared first and then multiply it by 15 pi, and I get 15,268.14 cubic inches. And volumes can get very large depending on what the numbers are involved. So just because you get a big number doesn't mean something went wrong. So you go ahead and try this one. Be careful. They do not give you the radius in this one. They give you the diameter. So find the radius first and then find the volume. Pause when you're ready to see the answer. Hit play. All right, so R was really 5.5. My height was 21. So volume was pi 5.5 squared times 21, and we get 1,995.7 cubic meters. Example 5, if a cylinder has a height of 7 inches and a volume of 2,908.33 cubic inches, find its diameter. So if we take the formula for volume, which we know is pi r squared h, I'm going to plug in 7 for h, equals the volume that they gave me. So what I'm going to do is I could either divide first by 7 and then by pi, or by 7 pi. I'm going to put that inside parentheses so I know it divides by both together. So when I do that, I get r squared equals 132.25. And now when I take the square root of both sides, I get r is 11.5. And they asked for the diameter, so I'm going to double that. So the diameter is really 23 inches. So you go and try this one. We're looking for the radius. Pause. When you're ready to see the answer, hit play. All right. So here we have pi r squared times 30 equals 589. I did divide separately this time. So first I've divided by 30 and then I divided by pi. So I get r squared is about 6.25. So r is about 2.5. So now we're going to talk about density, mass, density, and volume. So mass is really like the weight of an object. Density is the measure of how much mass is located within a specific volume of space, and then volume is the amount of space something takes up. So density is not necessarily associated with size. So small objects with a large mass, with a heavy weight, can have a high density, like ball bearings or gold bars, but large objects with a small mass, like a low weight, can have a low density, like balsa wood or hot air balloons. So we have three different formulas. I will generally start with the fact that density equals mass over volume, and then I'll convert it to one of the other two depending on what I'm looking at, because I know density is usually listed as something over something else. So the example here is grams over cubic centimeters. So if I know that density is supposed to be a weight over a volume, I know it's mass over volume. And if I need to find a different thing, let's say I multiply by V, so V times D would equal M, which is what they have here. Here, M equals D times V. And if I wanted M alone, I would divide sorry, if I wanted V alone, I would divide by D now, so V equals M over D, which is what they show us here. But this is generally the one I'm going to start with. So here we have a gold bar. It has a density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. So notice here these are in inches, but it gives us the density in grams per cubic centimeter. So what I'm going to do is I'm going to convert all of my lengths into centimeters first. So I would multiply each one by 2.54. So 7 times 2.54 is 17.78. 3.625 times 2.54 is 9.2075. And 1.75 times 2.54 is 4.445. So I'm going to find the volume because I know that density equals mass over volume. They're asking us to find the mass, which really means V times D. So I need to know volume, multiply it by the density to get the mass, which is what they're asking for. So let's start by finding the volume. I can call any side the base here. Let's say we call this side the base. So that's going to be through 9.2075 times the 4.445. That's the area of the base times the height, which is 17.78. And if I multiply all of these numbers, oops, typing in my calculator wrong, I get a total volume of 727.688 cubic centimeters. So now we're going to go back to this equation and say that the mass equals the density, 19.3, times the volume. So if I multiply the answer I had in my calculator by 19.3, I get a mass of 14,044.37. So we'll just round it to 0.44. And then that's in terms of grams. So you go ahead and try this one. It's the same idea. We are given a cylinder in terms of inches. You have to convert it into centimeters first because we are told the concrete has a density of 2.3 grams per cubic centimeter. So go ahead and try this problem. Pause. When you're ready to see the answer, hit play. All right, so I got a mass of about 2,182,485 grams. We have one final problem. A rectangular block of copper metal weighs 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. From this data, what is the density of copper? So we're going to find the volume. The base could be 8.4 times 5.5, and the height would be 4.6. All right, because it's a rectangular block, I know that the bottom has to be a rectangle, so that's why I could just do length times width. So we get a total volume of 212.52 cubic centimeters. Since density equals mass over volume, we know the mass or the weight is 1896. We know the volume is 212.52. So if I were to divide this, I would get about 8.92. And now I'm going to go back to the units of these. 1896 was in terms of grams. The 212.52 was in terms of centimeters cubed. So if we look at the units here, it's G over cm cubed. and that is section 11.5.